I request you all, if you can open your camera, we can take a shot. If possible, please open your camera. Okay, thank you. So this session, we are going to talk about hands-on on data visualization, and among us, we are having Dr. Mubarak Mujahid. Already, I have introduced him. So now I request you to please uh, start the lecture. Thank you.
Yeah, thank you, Dr. Kushwa. Uh, I hope like you are having amazing time here online. Of course, like if it were in person, there would have been more interactions. But whatever sessions you have been through so far, you must have been very.
இது வந்துட்டு டெல்லியில உள்ள
Sir, 1 minute. I request you to please switch off your
டெல்லியில உள்ள
microphones.
இந்த ஏஐசிடின்னு சொல்லிட்டு இன்ஜினியர் காலேஜுக்கு எல்லாத்துக்குமே ஹெல்ப் ஆகும் தான் டெக்னிக்கல் எஜுகேஷனுக்கு எல்லாமே.
Okay, sir. Sorry. Thank you.
No worries, no worries. Okay, perfect. Uh, so I was just looking through your program, and I can see that you have got really good introduction to IoT. Uh, then you have seen like how to communicate with your IoT device. In the morning section, I could see like there was some kind of MQTT protocol for IoT. So you know how to get a data from IoT device. But once the data is out of IoT device, once it is on your server or on your machine, the next thing is how to see this data, how to use this data, and how to communicate this data with your user. And there comes today's topic, which is data visualization. It is going to be a little bit of hands-on session. If you have access to laptop, I would strongly recommend to use laptop. If you're using cell phone, you can keep on using your cell phone, but again, actually get hand-on with your laptop or with your machine so that you can do some of the things which we'll be doing or covering in this session. Okay, so let me pull out my slides and then I'll start. Okay, perfect. So as I mentioned, today's topic is about data visualization. So what I'm going to do is I'm going to briefly mention about data visualization, some history of data visualization, some of the types of data visualization which we use in IoT realm, and then we'll start actually playing with Python and we'll do some kind of hands-on sessions or hands-on activities in Python. So when I talk about visualization, the very first thing what I would do is to go to any dictionary. Right now, I accessed Oxford English Dictionary and looked for visualization. And in the Oxford English Dictionary, there is a really nice definition of visualization. Now, what is visualization? It is the action or fact of visualizing. The power or process of forming a mental picture or vision of something not actually present to the sight a picture thus formed. Bit complicated, but it is giving really nice idea of like what visualization is about. It is about forming a mental picture of something which is not present. We have got a data, that data is in some form, we have to convert that data into something which is kind of more illustrative into the pictorial form. So if we look for more technical uh, definitions, then data visualization is a graphical representation that expresses the significance of the data. And that is the key here. We don't merely do data visualization to plot something. We essentially have to get the value out of the data, and that's why we are doing data visualization. It reveals the insights and patterns that are not immediately visible in the raw data. For example, if you have data in Excel format or any other format, that data is not giving any information. But with visualization, we are going to reveal more insights and more patterns about that data. So I have a really nice and cool website here, and it will show like how impactful is data visualization. So there is a nice website called Baby Name Wizard, and what we do here is we have something called visualization tool about baby names. Of course, I mean, these baby names are from Western world. So I'm not going to use Satish or Praveen or anything else. I'm going to use John, Mary, maybe perhaps Sean. So let us start with John, for example. If I go to John, so what I can see is in early 1800s or in late 1800s, John was very popular. Then popularity decreased. It again picked up some popularity, and now the John name is not used that much. The same thing has happened with Mary, for example. If I go to Mary, then in early 1900s, Mary was very popular, and now there are very few baby names with name Mary. There are some names which are actually spiking for some duration. Let us go for Sean. It is because there was Sean Connery. What we can see is that Sean was not used earlier, but after 1950s, Sean picked up, and now it is again decreasing. Let us go for one more example with Alex. And then what we can see is that Alex was not used much often earlier, but nowadays Alex is quite popular. So these kind of insights can be gained only if we could do a proper data visualization. So let me close this one now. And in today's session, we are actually going to look at some of the aspects of this data visualization. So as I mentioned, data visualization is all about turning invisible into visible that people can understand intuitively. Now, I have a really nice image over here. Can anybody tell me what this image is about? Anybody remembers this image? It was a very popular image recently. Okay, fine. Now, this image is the image of a black hole. This image shows the shadow of a supermassive black hole at the center of M87, which is Messier 87, which is one of the elliptical galaxies. So it is a black hole which is represented, pictorially represented for normal people or common people to visualize. We can do the same thing with other things as well. For example, we have one of the images here, which is the computer tomography of brain. And what we can see here is we have actually represented all the data about our brain using some kind of visualization techniques. One more example is the COVID data. Uh, it is a bit difficult if we actually show this data to common people with some charts or with some bars. But if we could show them through some animation, through some kind of visualization, then that gives more value to the data, as well as we can get more insights into it. So one more example over here. So now, why do we do visualization? As you might have seen so far, the main goal of visualization is to communicate information clearly and effectively through some graphical means. It does not mean that our graphical representation should look boring or should look very sophisticated. As long as we are able to convey our data to our users, we are okay with that. What we have to do is we have to convey the ideas both in the aesthetic form as well as per the functional needs. So data visualization should fulfill all the requirements for aesthetics as well as functionality, and to provide some more insights into rather sparse and complex data set. Okay, so this has been, we have been doing data visualization for some time, and one of the pioneers of data visualization is William Playfair. We call him as father of statistical graphics, and he was one of the persons who created the area and pie charts. So what this picture represents, maybe I can just elaborate this picture. What this picture represents is the comparison of exports and imports of England. So exports from England and imports into England from Denmark and Norway. And what he has done is, like, he has actually just plotted two lines: the line of exports, which is a red line, and we have a line of imports, which is yellow line. And what he did is, like, he filled the area spanned by these two lines to just visualize what is the balance against, or what is the balance in favor of England. And what we can see is that up to 1755, there was balance against England, which means, like, there were more imports than exports. But after 1755, there was balance in favor of England, which means England was exporting more goods than it was importing from Denmark and Norway. One of the other examples of data visualization, which we all know, is the visualization of cholera epidemic along the Broad Street in London, in Westminster. So John Snow was a physician, he was a doctor, and he was actually curious to know why cholera is spreading in certain locations in London. So he actually went and looked for a map of a broad street, and he actually visualized all the fatalities, all the cholera patients along the Broadway. And what he found is that there are more number of cholera patients along one of the pumps. And what he suggested is to just change this pump, clean this pump, and when they clean the pump, the cholera epidemic died away. So that is the power of visualization. John Snow converted some useful data into visualization, got more insights into number of fatalities, number of cases along the Broad Street, and then he pinpointed what is the exact cause of cholera epidemic. We have another example, very good example of data visualization, and it is by Charles Joseph Minard. What he did is, he did data visualization of Napoleon's Russian campaign in 1812. What he did is, he represented 3 or 4, rather not 3 and 4, rather 6 different entities, 6 different parameters onto a 2-dimensional map. So what we can see here is the breadth of this line shows the amount of troops. So as you can see that, like, as Napoleon marched towards Russia, towards Moscow, the amount of troop shrinked slowly. And when they returned, actually the troop was very small. I mean, like, almost 1/20th of troop, rather 19 out of 20 soldiers died during this campaign. And that is nicely represented over here. What other things are represented here is elevation. So here is, I guess, the Polish border. From Polish border until Moscow, there is a steep elevation. So the elevation is shown over here. Along with that, they have also shown the date and time as well as temperature data. So all that data is represented in a very nice form. Of course, I mean, this is written in French. I do have some other data which is in English and which is actually more elaborative. So this is the one. So this is the troop which is moving from Poland to Russia and from Moscow back to Polish border. And then we can see that, like, there is a shrinkage of troop. The elevation change we can definitely see. We can see the time, we can see temperature, and everything is represented onto this data. Perhaps actually I have written over here. There are 6 types of data in 2-dimensional: number of troops, distance, temperature, latitude and longitude, direction of travel, and location relative to specific dates. All this data is nicely represented into this data. Now there is one more historical representation done by Florence Nightingale. She was a nurse during Crimean War, and what she did is, like, she actually plotted number of deaths or number of casualties in the Crimean War. And what she found is that most of the people, most of the soldiers died not due to wound, but due to the unhygienic conditions in hospitals. And then she recommended to elevate the level of sanitization, cleanliness into hospitals so as to reduce the fatalities or mortality rate into that hospital. So all these things could be possible, were possible only due to the use of graphical representation or data visualization. So if I ask you a question, then what are the goals of data visualization? Can you give me an answer? Just type into your chat box and then let me see, like, what you think about it. What are the goals of data visualization? Okay. Sorry, I couldn't hear you. Yeah, perfect. I mean, like, some of you have mentioned that it is D, and that's the correct answer. Of course, I mean, like, I just wanted to show that, like, you are all attentive. So we use data visualization to explore. We think that there are certain unknown things, and we use visualization to do some kind of data exploration. We also do visualization to analyze the data. There are some hypotheses. We use visualization to verify or falsify those hypotheses. And of course, we use data visualization to present some facts. Whatever we know about the data, we try to present it in a very simple manner. And that's how we can get more value to our data. Now, I'll be a little fast. So this data visualization, the era of data visualization started in the United States in 1987, when the National Science Foundation started a new discipline called visualization in scientific computing. And the ACM, Association for Computing Machinery, used the term scientific visualization. So what is scientific visualization? It is the use of computer graphics for the analysis and presentation of computed or measured scientific. Now, there are some types of data visualizations. One of the types of data visualization is information visualization, and the other one is visual analytics. So we do some kind of information visualization for the data which has no inherent structure. For example, stock market, top grossing news, movies, social media connections. And then we also use structured data for the visualization. Uh, but in IoT, we have 7 different types of visualizations which we use very often. And those are written over here. So the types of IoT and sensor data visualizations are time series. If we have sensor data, if we have IoT data, all the data is time stamped. We also use ranking. We do part to whole visualization. We see the standard deviation, correlation, we see distribution, and we do comparison. So these 7 types of data visualizations are very common in IoT and sensor visualization. So I'm just going to skip some of the slides because these slides are meant for undergraduate students. And of course, like you all know these basics, so I'm just going to skip this one, but I'm just going to tell what is there in these slides. So we use time series, we use ranking, where we use bar graphs, we use dot plots, we use part to whole, we see deviation, distribution, correlation, comparison. So, and by doing all these things, we get more insight into data. Now, there are some other visualizations as well, which I didn't mention. For example, there are some schematics, there are some illustrations, there are some flowcharts. Perhaps like it is easy to show some data in tables as well, because we might have a small table and that table itself shows good amount of information. And then it is perfectly okay to just represent tables. Photographs are other, or like photographs are one of the great ways to show the experimental setup or the examples of actual results. And all those come under data visualization. Now, one of the things which I always mention to my students is not to use pie charts. Until 1990s or 1995, in our era, we were actually heavily using pie charts. But there are some difficulties, there are some problems with pie charts, especially when we're talking about big data, and especially we're talking about the IoT data. So specifically for IoT and sensor data, pie charts are poor at communicating data. They take up more space. It is harder to read. And cognitively, our brain is not very good at comparing the size of angles. And if we actually keep on actually showing the size of angles, then it will be a little complicated and it will be a little complex. So I often actually try to avoid pie charts, but then there are certain things which can be very well represented using pie charts. If we have less amount of data, if we need to show really good comparison, then of course pie charts are useful. But for big data, I never recommend using pie charts. Okay. So if we want to create some kind of visualization, we have to actually ask 2 questions. What we are ultimately trying to communicate with our audience. The very first thing is like, we have to find what is our audience. Once we define our audience, then we have to actually ask the question, what we are ultimately trying to communicate. And the other question which we ask is, which visualization best achieves our aim in clearest manner possible. And that is the key. There might be many visualizations. We can use bar charts, we can use some actually maps, but what is the best and clearest way to achieve our communication aim. And then that's why we actually ask some more questions. So what data is relevant for your aim? What is the audience? How to encode your data? How to structure the visualization? How to demonstrate the relationship between data? What is the scale to use for our visualization? What elements will be used to interact with our users? And then we also have to think as a user and then ask a question, will a user intuitively understand how the visualization works and what it represents? So whenever we are making any visualization, we try to see or we try to address all these questions. Now, there are certain design principles. There are some do's and don'ts, which are very obvious, but I always actually tell it to my students to look into those. The very first thing is to use colors and other aesthetics properly. For example, I have this image. Uh, so if you could read this one, then you are still younger. But if I want to read it for some time, then my eyes will get actually tired. But instead of just using the background color, which is little bit brownish, yellowish, if I use blue color, then I can now read it very well. So the very first thing is whenever you are using data visualization, don't make it very bright, don't make it very lousy. Make it which is very simple and use colors very, very wisely. Another thing what we do is we try to create some kind of illusions in our data. For example, here, the data inherently may have some kind of illusions and that may get carried out in your visualization, or perhaps you might actually work on data to just make it a little bit polished, make it a little bit looking better. And in that, you may create some kind of illusions. So the very basic thing, very first thing what you should look into your data is to make sure that like you are not using any illusions. And if at all there are some illusions in your data, you are going to eliminate that. Now, there are some kind of design principles. One of the first principles, a set of principles is by Gestalt. And then there are some other principles by Tufts and others. So I recommend you to go through these principles and actually look into those in more details. I'm not going to cover them today because we have limited time and I want you to do some kind of hands-on activities. So look into it whenever you get some time. I have some useful links over here which do mention about data visualization. One of the best one is the first site, which is infogram.com. Very good website, and it actually takes you deep into the uh, area of data visualization. It talks about do's and don'ts, practices, the best practices to do data visualization. Some of the data, uh, which is big data, how to represent that big data is nicely actually mentioned in the third link, which is flowingdata.com. Then there is another website called visualloop.com. So go to these websites and try to capture some of the parts from there. Okay, so I'm just going to turn off this uh, power presentation and I'm going to actually pull out my other slides and then we'll do some kind of hands-on activities. Okay, so let me close this one. pull out my other presentation. Perfect. Yeah. So I hope like now you are able to see the presentation properly. Uh, if you cannot see it, just let me know. So what we're now trying to do,
I think presentation is not
it is not
visual, sir.
visual. Okay, perfect. Thank you.
Now it
Perfect.
is
Yeah. Thank
visible,
you very
sir.
much. Thank you. Okay. So what we're going to look into is to get some kind of introduction into data visualization. And for that, we are using uh, Python programming. So I hope, I mean, like many of you are aware of Python programming, but then there might be some people, few people who may not have access to Python. So in today's class, we are actually looking into this data visualization from students' perspective. So I'll be starting from scratch, right from how to install Python until actually making some plots, making some graphs. Okay, so what I'm going to cover is introduction to data visualization tools in Python. Then we'll do some kind of basic plotting in Matplotlib. We'll actually look into line plots, area plots, histogram, bar charts, box plots, scatter plots, how to actually make them. And then I'll go for some kind of advanced visualization tools in Python. We may not have enough time, but what I'll do is like I just cover some of the slides and I keep all the material in my slides. So when I distribute my slides, you will have that as a reference and then you can do all those things on your own. So all these slides are self-explanatory. But if you have any questions or concerns, you can always email me and ask for any doubts or something. Many of you have actually sent me emails. I'm replying one by one. But if I have not replied to your emails, just be patient. I'll be actually sending you replies shortly for my first presentation. Okay. So let us talk about Python. I know many of you have been teaching Python for some time. Many of you have been using it for some time. Uh, but for those who don't know anything about Python, here is something for you. Okay, now what is Python? It is kind of funny language, I would say. Uh, it's very easy to use, but it is very high level language. And it is designed to emphasize the code readability. So if I want to teach any programming language to my kid, I would start with Python. Of course, I mean, I'll start with some kind of visualized programming language like Scratch. But after Scratch, I'll start with Python so that actually they can do programming very well. This programming language Python helps programmers to write clear, logical code for small as well as large scale projects. I'm just going to skip this one. There is really nice book called Automate the Boring Stuff Using Python. I recommend you to actually download this book. If you go to archive.org and look for this book, it is available for free. Of course, I mean, you cannot download it, but you can actually loan it. Or I would strongly recommend this book to have it in your library. So just talk to your librarian and get this book for yourself as well as for your students. It is by A.I. Schwegert, and it is free to read under Creative Commons license. Now, why I'm choosing Python for plotting? Because very first thing is it is easy to automate codes. It is very easy to integrate with data analytics and processing. So I don't require anything else for my data analytics or data exploration. So I can do data analytics and processing while I'm actually thinking about my data visualization. It is a full high level language, as I mentioned just now. And again, coding is fun in Python. One of the packages in Python is matplotlib. It is very comprehensive library for creating static, animated, as well as interactive visualizations. The output is of publication quality. You can just actually pick that output as a JPEG file or any PNG file and actually just straight away send it to publication. Very powerful. It has got many extensions. Since it is open source tool, we have a lot of help available online. So whatever Python I have learned so far, I know very little about Python, but whatever Python I have learned so far is through the community pages, just going through community pages and actually putting my queries and actually trying to know more about my queries. There are some plotting libraries for Python and which will be using it very often. They are known as NumPy, SciPy, and IPython. So these are the libraries which we'll be using along with matplotlib for our data visualization. So this matplotlib was developed by John D. Hunter. He was neurobiologist. Remember, he was not engineer. He was neurobiologist, and he wanted to visualize the electrocardiography data of epilepsy patients. And he tried using MATLAB, and the MATLAB couldn't actually give him proper output. So he actually worked on it and like he invented matplotlib. So matplotlib is very commonly used in scientific computing. I have already given one example of this black hole, which is actually plotted or visualized in matplotlib. And this matplotlib was used for data visualization for the landing of Phoenix spacecraft in 2008. And since then, like it has actually picked up very high popularity amongst Americans as well as in European and Indian subcontinent as well. Here are some of the nice examples of matplotlib. We can actually plot line plot. We can have histogram. We can have scatter plots, 3D plots, image plot, and bunch of different plots, polar plots, line plots, again, 3D plots, and image plot. Now, matplotlib has a very simple architecture. It's a 3-layer architecture. We have the backend layer, where actually we decide where it decides a renderer, and we decide like how it should be rendered into the backend layer. Then we have another layer, which is the middle layer. We call it as artist layer. Many of the time, we don't look into artist layer and backend layer. Artist layer is essentially, as it mentions, all the artistic activities are done in this layer, and it also looks for what should be rendered, and many parts of the plots are actually defined and processed in this artist layer. In the very upper layer, which is scripting layer, we use pyplot, and the users use this scripting layer to make some kind of visualizations. If you want to dig more into artist layer and backend layer, they're very easy to follow and they're very easy to understand. But this is not, those two layers are not the scope of today's presentation. We'll be just looking at scripting layer, and we'll be actually just scratching the surface, and we'll be just actually going through some of the basics of Python. And then at the end, I'll show you some of the examples of how it can be used for data visualization. So first thing first, I know, I mean, like, if you have been using Python in Linux or on Mac OS, it is already installed. But if you're using Windows machine, or if you are very new to Python, or if you want to actually teach Python to your students, I will recommend downloading Anaconda and using Jupyter Notebook for your data visualization. So go to anaconda.com and try to install Anaconda onto your machine. And if you have enough bandwidth now, you can do that with me. So let me go to anaconda.com and see if we can actually download it. I have already, let me just do it. I'll show it to you. One sec. So what I'm going to do is, like, I'm going to Google anaconda.com, and here go to products and go for individual edition. You can of course go for commercial and team edition, but that is not required if you want to actually teach data visualization to your students. Go to individual edition and click on download. I already have installed it, so I'm not going to re-download it, but the download is very easy. Just click on this 64 or 32-bit graphical installer for Windows. Again, same is true for Mac OS and Linux. Okay. Okay, I have some comments here. My voice is broken. I hope, like, I was properly audible. If not, I will actually just go a little slowly. Okay, thank you. Yeah. Okay, so you can actually go to anaconda.com and install Anaconda. Once you install Anaconda, what you can do is you can go to Jupyter Notebook or Anaconda. I can actually just go to Anaconda Navigator. I just click over here, and what I can see is a Anaconda IDE. It's loading. It's loading on my other screen, but once it is loaded, I can actually show it to you on my main screen. Okay. I'm not okay. Okay, it's taking some time. I don't know why. Typically, it should take no more than a minute. Okay, perfect. So once you actually click on that, then you get a bunch of options, and you can actually ask your students to play with this environment. What I'm going to do is I'm going to use Jupyter Notebook. It is a web-based interactive computer notebook to edit and run your codes. Very easy to use. So just click on launch, and then you might be able to see your first Jupyter notebook. Now, many times you might be using your notebooks remotely, and you may not have Anaconda installed. In that case, just go to Jupyter, yeah, jupyter.org, I guess. Yeah. And then from there, you can actually run it live. So you need not have to install anything. Okay. You can just actually click on try it in your browser, and then you'll be able to use it easily. Try Jupyter Lab. Let's click on that, and then you'll be able to use it. Of course, I mean, my internet is a little slow, so it may not come very quickly, but I just wanted to show you that. So either you can use web-based browser, or you can actually install it and use it in your web browser. Okay, it's coming anyway. Okay, so let us go to our homepage. So it is very basic. structure, go to new. Once I go to new, click on Python 3. So what we have done is we have started a new notebook. This new notebook is where we are going to put all those codes. I'm just going to rename it. I'm just going to use FDP IIIT. Just use FDP IIT. That should be enough. Okay, and then we can start now writing our code. So the very first code which we will write is, just give me a minute, is just we'll do some small calculations over here and over here. Is just to print hello world. So what you can do is like you can just do some kind of things. I'm just going to skip this one because you are all good at programming. So what we'll start with is importing matplotlib into the environment and start plotting something. I'm just going to end this one. And I'm going to just go here. So the very first thing what I'm going to write is import matplotlib dot plot as PLT. So by doing so, I'm importing the matplotlib library into my Python environment. I'm just going to press Shift Enter and no module. Okay, I did some mistake. Matplotlib. Yeah, it will run now. Okay. So I have imported matplotlib as PLT. Now, once I have actually imported this matplotlib, it is now very easy to plot any of graphs. So let us do some kind of scientific plotting. Maybe we can actually plot a scatter graph. So I'm just going to write plt dot plot, and this is, and maybe I can just write random numbers, maybe 1, 2, 2, 4, and 10. Enter, and then you can see that we have a scatter plot available here. Very easy, no thing. I mean, like, no mess. Now here, what it has done is like we have not actually mentioned the x axis values. It is just showing actually y axis, and then you can see that like it has taken 1, 2, 3, 4, or it has started from 0 and it has gone up to 4. So it has taken 5 x values and corresponding y values. Now what we can do is we can also play with this, and when I'll actually show you or like share with you the PowerPoint slides, you can actually capture some of the examples and run it on your own. What I'm going to do is like I'm just going to plot something for you here very quickly. I'm just going to put it over here. So these are the y values. I'm just going to put some x values as well. I'm just going to put 1, 2, 3, 4, 5, comma. And then what I'm going to do is I'm just going to go for some kind of color. So I'm just going to put arrow. Okay. And I'm going to actually plot this one. So now I have defined my x values as well as y values. And I have also actually asked the second layer, which is artist layer, to plot the red dots instead of actually having straight lines. Straight lines are by default, but if we actually want to change these straight lines, so first R is for red and O is for dot. So by putting R and O, I'm going to go for red dots. Now, of course, I'm like, if I want to actually plot something else, I'm just going to copy it from here. I want to draw 2 sets of points. Just write this one and enter, and then I can actually have 2 different types of data sets. Now here, earlier I had used R and O, so it was red dots. Now here I have written B and star, which means it is blue stars, which you can see over here. Very easy to follow and very easy to understand. And now let me write some of the things which are a little uh, bit complicated. What I'm going to write here is, I don't have any legend here. So I'm going to put some kind of legend and I'm going to place that legend properly. And then I'm going to show it. So I'm just going to copy it from here. Okay. So what I'm going to do is, I have this data set, which is 1, 2, 3, 4, 5. And these are the Y values, red dot. Then I have another data set with blue dot. Now I want to label this with red dots and blue stars. So I'm just writing label is equal to this. And I'm just going to give a plot title. So a simple scatter plot. I'm going to put a Y label and X label. So we'll have a proper graph over there. And then I'm going to actually choose the location of the legend as the best location. Okay, so I'm just going to put best over here, and then I'm asking the second layer to show the plot. And let us see what is the output. And here is the output. So it is as if using MATLAB, which you have been using for a long time, uh, but it is much simpler than MATLAB. Okay, perfect. So let me see, if I have any other example for scatter plots. Okay, anyway, it doesn't matter. It might just get complicated. Okay, perfect. So what we have seen is creating a scatter plot is very easy. If you want to actually plot some specific chart, for example, bar chart, histogram, just put hist instead of plot, and then you can get histogram and everything. Okay. So those who have access to your computer, and if you have a proper bandwidth, try installing Anaconda immediately and let me know if you have any problems. I'll wait for a couple of minutes. By that time, if you have any other questions, you can keep on asking. I'll wait for just 5 minutes and then we'll go to the next portion, which is advanced data visualization using uh, Python. Okay, now there is one question by Professor Dicholkar, and she's asking like if some data is imbalanced, how we will come to know or which plot to be used. And that is what I'm going to cover in next few slides, as well as I'll cover that in the next class, which is about Power BI and using some kind of IoT platforms, where we do some kind of exploratory data analysis and we see the size and shape of the data. We also look for some missing values and we try to actually replace those missing values with certain parameters or with certain strings. So those examples I'll take after some time. Okay, so now what we'll do is, I hope like you all have installed Anaconda, or you already have access to Anaconda or Jupyter Notebook on your machine. So we're actually going to do a small tutorial on how we can use Matplotlib or perhaps actually Python to do some kind of visualizations. For that, uh, I generally download data from one repository, and I'm going to show that repository to you. Give me a minute. So I generally go to UCI machine learning repository. UCI has really nice data set which you can download. So let us go to that and see how it looks. I'm just going to click on the link and see how the data set looks. UCI machine learning repository, you can see that like we have a bunch of data sets which are getting updated or uploaded on daily basis. Uh, so one of the most popular data sets in the history is this iris dataset. It is very simple and very straightforward data set. And with iris dataset, we can do many things and many uh, uh, concepts, small concepts uh, for learning our Python code. Sorry for that. Yeah. Okay. So what I want you to do is to go to UCI machine learning repository. Once you go to UCI machine learning repository, click on iris, go over here, and then you can actually download that data set from here. So you can just go to a data folder And from there, you can actually download iris.data and iris. Just download everything to your file. Okay, now what that data set contains? This data set contains uh, the sepal length and sepal width of a flower iris. It also contains petal length and petal width, and the data is actually classified into different species. For example, iris setosa, iris versicolor, and iris virginica. So these are the three species. So the data set looks very simple. I have already downloaded that data set, so I'm just going to show you that. Just give me a minute. Okay, I'm just going to go here. So what we have is a sepal length, sepal width, petal length, petal width, and species. And the data is very clear and very simple. So we're actually going to do some kind of exploration in this data using some of the Python commands, and then we're actually just after that we're actually just going to our tutorial. So I'll not take more than 5 minutes on this iris data set. Okay. So first thing first, what I'm going to do is I'm going to go to my library and going to use some of the Python toolboxes. Now, what are the Python toolboxes which I generally use? The very first Python toolboxes I use or libraries I use is NumPy. I otherwise use SciPy. I always use Pandas, and in many cases I use Scikit. Now, the NumPy is a library which introduces objects for multidimensional arrays and matrices, and it provides vectorization of mathematical operations. Pandas gives some kind of data structures and tools to work with. So if your data is structured data, go for Pandas. And it also allows, as we were just mentioning earlier, it allows handling missing data. That's the power of this Pandas. We can also use Learn Scikit, which provides machine learning algorithms such as classification, regression, clustering, validation, etc. So whenever we have any data set, the first thing what we do is we look into the data analysis. What we do is we find the shape of the data, type of data, and other statistical information so that we can make an educated guess about how our visualization is going to look like. So the first thing first, what we're going to do is we are going to import all these libraries into our Jupyter notebook. So let me just go over here and just type it. Import as ACC. Of course, it is not needed right now, but I'm just going to do it because you will just see this, and it's a good habit to import some of the files so that it will be otherwise easy to play with. Import. Okay, so I'm importing bunch of libraries. These are Python libraries. It might take some time. Okay, it was quick. Many times, like it takes some time because you don't have those libraries installed, or like you don't have those libraries downloaded. So it might take some time. But since like those were already downloaded in my machine, it was much quicker. Now the next thing what we're going to do is to look for the CSV file which you have just downloaded from UCI Machine Learning repository. So what you're going to do is to read this CSV file. And for that, we are using a command called df is equal to pd.read underscore CSV, and then the name of the Excel file or CSV file, which is iris.csv. So let us do that quickly. So df is equal to now it is as let us see what we get. Okay, now the iris.csv is now stored as my as df into this library. Just give me a minute. There's some issue. Okay, perfect. Yeah. So we have now df is equal to iris.csv. So now whatever we are doing, we are going to do with this df now. Now, first thing first, what we're going to do is we are actually going to look at this df. Now, what is df? I use df to use it as a data frame. So we are going to look at data frame, and we are going to look at the shape and size of this data frame. So what we're going to do is we are just going to look at the first 5 records. So what I can do is like I can just use df.read or sorry, df.read. So it is first 5, and then I can just you can enter. So it is now showing me the first 5 records in the data frame. And what we can see is that we have a sepal length, sepal width, petal width, and spaces. So now I kind of know what I'm going to play with it, and I don't know what exactly I'm going to visualize into my data set. Okay. Now, the next thing what I'm going to do is we can actually look for some kind of data types. What kind of data types we have in my data frame. So what I'm going to do is I'm just going to go for df.types, and when I enter it, I can see that the sepal length is a float, sepal width, petal length, petal width is a float, species is of course object, and the data type is again the object. So I know what my data is looking like, how my data is structured, how my data is shaped properly. Of course, I mean, I'm not actually going to ask you to do many things, but in my PPT, there are some kind of tutorials which you can actually follow, and you can see how each command can be used and how we can get more insights into our data frame. Okay, so I'm just going to skip many points, and then I'm just jumping into the next section, which is once we know how my data set looks like, I'm now going to actually play with my data set. And that's why what I'm going to do is I'm just going to actually make some kind of subsets into my data frame. So I'm just going to select a column in a data frame. So there are 2 methods. One is we can make a subset of the data frame using column name, or we can use the column name as attribute. So if I just use, for example, PF, then maybe I can actually just go for what I have is sepal length, I guess. Sepal length, yeah. And then if I actually just enter, I can actually just see my sepal length column. I did not have to actually just look into anything else. So I can actually just select one of the columns and do some kind of data analytics onto that. But of course, I'm not going to do it now. Okay, so this is how you can actually do some kind of exploratory data analysis onto your data and try to find out what different types of analytics you can use. I'm just going to share that with you. We were here Okay, I just actually skipped all the slides. So there are some kind of different data frame attributes which are written over here. Uh, we can use some kind of data frame methods to look for different attributes. So for example, if I use df method, for example, head, tail, describe, then I can see different portions of my data set. If I use std, for example, I can actually see the standard deviation in the data set. If I use simple sample, then it returns the random sample of the data frame. And the next one, which is very important, which is drop NA. If I use drop NA, it drops all the records with the missing values. So if we have some missing values, then drop NA can actually drop all the records with missing values. Of course, we're not going to use this one. I'm just going to skip this one right now. I'm just going to skip group by method as well. I'm just going to skip this one. Okay. I'm just going to skip this as well. It's going to okay. So what I'm going to do is like I'm going to stop this presentation. I just wanted to show you how we can use Python to do some kind of data exploration. I'm going to do some kind of live examples to visualize some data in real time. Okay, so I'm just going to close this one and let me stop sharing. And I'll actually pull out another presentation. Okay, I have one comment here, how to open Jupyter tab in browser. So, Dr. Chatterjee, there are two methods. Let me actually just pull off this one and show it to you. So what I'm going to do is I'm just going to click on start. Once I click on start, then if you have installed Anaconda, then you will have an option over here called Anaconda Navigator. Click on that. Once you click on that, then you will get this environment. Into this environment, look for Jupyter Notebook here. Click on launch. So if you click on launch, then the Jupyter Notebook will open. So that is one way of doing that. Another method is just go to start and look for Jupyter Notebook, click on it, so your Jupyter Notebook will open in a browser. If you have not installed Anaconda, if you have not installed anything onto your machine, what you can do is you can just go to jupyter.org, and over there, there is a tab called Use Web Browser Based Jupyter. Just click on that, and then your Jupyter tab will open. Okay, so what I'm going to do is I'm going to use Python for some kind of different data visualizations. And since we are actually short on time, I'm just going to go through those slides, and maybe what you can do is you can actually take that as a challenge, do some kind of self-study with my slides, and contact me anytime with your queries and with your questions. So the topic is advanced data visualization in Python. So in this module, what we're going to look at is waffle charts and word clouds. And we're also going to look at how we can use or how we can visualize geospatial data if we have some time remaining. Now, waffle charts are used very often. They are very easy to understand, easy to digest, like waffles, and they're quite tasty as well. We can actually get more information about our data using waffle charts. It is useful if there are not too many items to put in. If we have 50 or 60 or 100 items to put in, then I will not recommend waffle chart. Then it will actually go into the same lines with pie chart. The reason I actually don't go with pie charts is because it doesn't give more information and it is not good for large data sets. Same is true with waffle charts, but at least waffle charts gives more information than pie charts. So for waffle charts, what we require is NumPy library, pandas, and matplotlib library. We can import those. And here, what I have done is like I have created some kind of imaginary data frame. So I have actually created a data frame of number of medals owned by 4 states. So my data frame DF looks like state, which is Maharashtra, Kerala, Goa, and Odisha. And medals are 800 something, some numbers. And when I actually look at this data frame, I have this data frame over here, or this is the table which I get. Now, what I'm going to do is now I'm actually going to take a sum of all the medals. So I'm just going to sum everything, 812, 334, 120, and 130. And I'm just going to look for total sum. Once I have total sum, then I'm just going to make the proportion for each state. And that's the key. So I have total number of medals as 1. And out of 1, how many medals owned by each state? And that is what I'm doing with proportions. And I'm going to find those proportions. And once the proportions are found, then I'm going to define the width and height of the chart. Here I'm using width as 40, height as 10. So the total is width times height, which is 400, which means now I'm going to actually put my proportionate data into 400 tiles. So I have these proportions. I'm going to put these proportions into 400 tiles. And that is what I've done here. So I've determined how many tiles will be allocated to each state, not country, state, of course. And then what I can find is that for Maharashtra, we have 233, for Goa it is 96, or Kerala it is 96, Odisha it is 37. So this is how we have prepared our data. Once the data is prepared, what I'm going to do is I'm just actually going to plot it. So I'm going to generate the waffle chart. So the first thing first, we will generate a matrix of all zeros. Once the matrix is formed, then we are going to replace the zeros with corresponding category. And then this matrix will resemble as the waffle chart. And then we can use a color map and map show to display this matrix. Very easy. Just put color map is equal to plt.cm full form. You can actually just change it as per your choice, and then write plt.matchshow waffle and cmap is equal to color map, which you have already defined over here, and then you can plot this color bar. So this data looks good, quite well, but what is missing is this data is not actually like waffle chart. So we have to actually create waffles for each of the state and for each of the points. So what we're going to do is we're just going to beautify all the elements such as sticks and grids, and we're actually just going to put all these grids and everything. And that is what is done over here. So we have done some kind of beautification using some of the techniques over here. Now the next thing what we're going to do is where we can add legends. So what I recommend is, like, I know I'm like this looks little clumsy. You can just copy it as it is try to understand what you're copying, and then try to run it so that you can learn how each of the statement is working. So here we are going to add some kind of legends, and once we put legends, the output is like this. Of course, I mean, the output is not proper. I guess there is some issue. That's fine. So it should have been blue. Kerala should have been light blue. Goa is what it is, what Maharashtra is, and Odisha is what it is right now. So that is the output. So this is a typical example of waffle chart, where we are actually converting the structured data into a matrix, and we are representing that matrix. And many a times the IoT data is structured data. So IoT data can be really nicely represented as a waffle chart. Okay, I'm just going to skip this one. Maybe we can use it. Okay, this looks better. I've used some kind of other class, and I'm just going to skip it. You can actually try it on your own once you get my slides. Okay, fine. Now, another way to visualize your data, non-structured data, is using word cloud. Word cloud is very popular, especially if you have unstructured data. Say, for example, you have IoT device connected to your social media. So the IoT device is going to give structured data, but social media data may not be structured data. And for that, you can use some of the visualization techniques such as word cloud. Now, what is word cloud? Word cloud, also known as tag cloud or wordy, is the visualization of text data to depict keyword metadata. Now, these tags are usually single words, and the importance of each tag is shown with different size and fonts. For example, if you know Malayali, we have some word cloud in Malayali. We have some of them in Hindi. We have some of them in English. I mean, there is no restriction. I mean, it is up to you how you want to represent. Say, for example, what are the fruits which you can actually use so as to keep yourself fit. And then, of course, one of the things which comes is amla, kathal, and everything. And here we have to try to represent like what one of the paragraph is talking about. Okay, so the workload is quite essential to quickly perceive the most prominent terms to determine the relative prominence. For example, what we did is like I went to IIIT website and copied some of the text from IIIT website and created a word cloud. And what I could see is that some of the terms which are actually prominent is Institute, Program, Pune, Engineering and Research, Tech. Then some of the other words are students, Indian Institute, course. I don't know why Trinity comes, but Trinity is there. Maybe it is indicating the location. So bigger the term means more weight. Smaller the word means smaller is the weight. So it is very easy to understand and easy to share. So it can be used for social media, customer feedback, SEO and summary. Let me just go over there. So what you can do is like for using word cloud, there is a package called word cloud. And many a times like you do face problem installing it nowadays because they are going to do some kind of changes to word cloud. So I would recommend to use one of the commands called pip install word cloud. So install it, and you can actually see that there will be a bunch of things which will be happening within a couple of minutes time. Okay, so you have to be patient if you want to install word cloud for the first time. Again, my favorite libraries, I use matplotlib, numpy libraries, which I'm going to import them. I'm just going to actually get some of the things. For example, I'm using PIL to import images. And then I'm just going to convert those images into arrays. And then I'm also going to import some kind of stop words. such as we all about. So these are all stop words, like, and we don't use those stop words. So we just eliminate stop words from word paragraph, and then we create a word cloud. So I'm just going to skip all these commands over here, and then I'm just going to show you the final thing. So this is the cloud which we get. So as I mentioned earlier, I went to IIIT website and I copied all this text, and this text is converted to a word cloud, which is shown over here. And one of the other things is, by default, the word cloud is shown in a square or a rectangle. If you want to actually overlay it onto some of the stencils, then you can do that as well. And that is what we have done over here. We call it as fitting the cloud in a mask. And for that, we actually went to IIT website and got this mask, a shield mask, and we actually tried to fit everything into this mask. It is shown over here. So we have a shield, and into this shield, we have actually put all our information. And then it is very uh, evident that it is showing some of the more keywords, such as Indian Institute of Information Technology, Research Institute, Engineering, Pune, of course, because it is located in Pune. So we have fitted our word cloud in a mask very neatly and very easily. We can also use maps in Python to represent data, and it is especially useful when we are actually showing some of the IoT data. And for that, we use Polyum, a very powerful package. We also do some of the maps with markers and some of the maps with chloropet maps. And what I'll do is, like, I'll actually bundle everything and send a package to you so that you can actually self-learn all these things on your own. Okay, just to give one example, this is the example of Folium, where we are actually have a leaflet map, and onto the leaflet map we're showing the data. And then we have some kind of, okay, I guess, okay, no, I don't have those examples. But what I'll do is, like, I'll bundle all the examples and then I'll send it to you. Okay, so let me stop here. I know, I mean, like, I rushed a bit, but it was just to give you a nice idea of what is data visualization, how we can use Python for data visualization, and what are the common techniques by which you can actually learn data visualization tools and disseminate that to your students. So I'll stop here. Maybe we can take a break for about an hour, and I'll come back and we will see some of the cloud IoT platforms. Perhaps actually I'll give some of the emphasis on Power BI, IoT, Azure, Microsoft Azure IoT, and I might actually talk about Things Board as well. Okay, so if you have any questions, concerns, just type it over here. I'll be here for some time, and otherwise I'll see you at around 2:30. Take care.
If we have any question, please type over here. Okay, I guess there is no question. Thank you, sir. We will meet at 2:30.